much. Perfect. So now we have a practice question that is related to the counting principle over there. So the question says 7 cars of a different manufacturer, of which 3 silver are to be pegged in a straight line. So we need to peg the cars in a straight line. We are not undergoing any restriction. There is no restriction in this case. We just have to peg the cars, okay, in a straight line. The first question is, how many different ways can all the cars be pegged? All of them, no restriction. We're just picking all of them in a straight line. So how many cars do we have? 7. And how many different ways can we count them? That's where you start to do your lines. So you're going to say 1, 2, 3, maybe 4, 5, 6, 7, like that. Those are the 7 spaces. And then you ask yourself, how many chances are there for the first space to be occupied? The number of chances are 7 because you still have 7 cars. Out of those 7 cars, 1 car is is placed there. So which means there are 7 cars, or there is 1 car out of 7. Yes, there is 1 car out of 7 that can occupy that space. Then if I take out 1, I will be left with 6 now. After 1 car has been pegged already, how many cars are left? I'm left with 6 cars. And then how many cars how many chances are there for the second space to be occupied? There are 6 chances for the second space to be occupied. So it's going to be 6. Why? Because only 1 car out of 6 will occupy that space. I hope this is getting to make more sense over there. So that's going to be 6. So I then take 1 car which has been placed over there. And then now I'm left with 5. And then 1 car out of 5 will occupy that space. There are 5 chances for that space to be occupied. And then there are 4 chances for this space to be occupied, 3 chances, 2 chances, 1 chance. And then you simply multiply over there. When you multiply, this is going to be actually just like when you do the factorial. When you multiply, this is going to give you 5 or 40, of which this is n number of ways. And then you can just do it like the 7 factorial. It will give you the same thing, 5 or 40. Because we talked about factorial, the number decreases until 1 over there in simple. So now, the second question says, how many different ways can the cars be pegged if silver cars are placed next to each other? Now we are pegging the cars, but we are putting into consideration that we have silver cars. So which means we have to make sure that silver cars are next to each other. All right, that's fine. So the way we're going to do it, we're going to do it like this. I'm going to open my spaces again. There are 7 spaces, 2, 4, 5, 6, 7 over there. But in this space, I'm going to have what? Silver, silver, silver. Those are my silver cars. Now I'm counting that as a unit, okay? Which means I have 1, 2, 3, 4, 5. Now I have 5 spaces that needs to be occupied. So I'm going to open here and say 1, 2, 3, 4, 5. Okay, that's fine. I'm going to do it like this so that you get it more familiar. Okay, so now you're going to ask yourself, how many chances are there? How many chances are there for the first? And the way I'm doing it over here, you must listen and understand it properly, because this is where we have a choice inside another choice, or a unit within a choice, or yes, something like that. Because we first we have the cars, and then we have the colors that need to be close to each other over there. So I hope that get to make sense a bit. So now the way we're going to do it, we're going to ask yourself, how many chances are there for this space to be occupied? I have 5 chances because I have 1, 2, 3, 4, 5. It can either this one sit there, this one sit there, this one sit there. this one sit there, this one sit there, over there. Then when that car is already placed, how many now? Let's say that car was placed, the car over there was placed, and then now, how many chances are there for the second car, for another car to be placed in that spot? You have four chances left now, and then you have three chances, you have two chances, you have one chance. But the question now is, let's say we were in a case whereby in this space it was the unit which was placed there. We have to consider that inside that unit, and if they're just a silver car, you might find that the other one is BMW, the other one is Polo, the other one maybe is whatever the cars, Toyota, and then Isuzu, Suzuki, whatever. So there are three of them. Let's say BMW, Polo, Toyota. So now, even inside the unit, you're going to say, okay, it's either um BMW occupy this space, Polo occupy this space, Toyota occupy the space, or it can either be Toyota occupying this space, Polo occupying this space, BMW occupying that space, or it can be the other way around. The way you do it mathematically, you are going to say how many cars are there inside the unit. How many cars are there inside the unit? I have three cars. So the first space or the first slot will be occupied by one car out of three cars. It might be BMW out of those three. So the second space will be occupied by one car out of two that will be left, maybe Polo and Toyota. And then the last one might be three over there. So the way you do it, you come and multiply over there by 3 times 2 times 1, of which it is for the unit. The way we're doing it, we're assuming that what if it was on the first space? What if it was on the second space? What if it was on the third space or the second or the fourth space, whatever it is? So, which means now the number of ways are actually going to be um that's actually going to be 720 over there. But the other way that you can do it, you can say, okay, how many how many ways can I peg the cars? Okay, how many ways can I arrange the cars? We're dealing with arrangement, and you can say I can arrange the cars in 5 factorial. How many ways can I arrange the silver cars? I can arrange the silver cars in 3 factorial. That's 5 factorial times 3 factorial, which is 720 over there. 720 ways. So in exam, depending on your understanding, you can just do it any way that you understand it. So now the last question says, what is the probability that the cars can be pegged if silver cars are pegged together? So we haven't been talking about probability. You know that probability is actually the event over the sample space. That's probability, the event over the sample space. So what is our event? Our event is silver cars pegged next to each other. That's our event. Silver cars pegged to each other. And then what is our sample space? Our sample space was 7 cars. Okay. And then the way you are going to do it here in counting principle, probability, you always divide by the total of the the total, the sample space in this case, I mean the total, which is your total number of cars or total arrangement without any restriction, of which it was going to be 7 factorial over there. So which means you are actually going to divide by 7 factorial, which is I think it is 5040. But then Your event was the number of ways in which the cars can be pegged if silver cars are next to each other, of which it was what we answered on B over there, of which is going to be 5 factorial multiplied by 3 factorial, of which I think it was 720 over there. So when you do it like this, when you do it in your calculator, I think you get, from my calculator, I get 1 over 7. This is your probability.